Data is the new science. Big data holds the answers. With this, I, Dr. Harshita Vachhani from Pratibha College of Commerce and Computer Studies, welcomes you to step into the recent trends in IT. We will be taking a small tour on today. We will be taking a small tour on big data analytics, which is a new and the latest trends nowadays in IT industry. So, friends, let's start our tour. So, by this, let me share my screen. So, today, the takeaways from today's session would be we'll be taking a tour like what is the data, what is big data, what are the examples of big data, types of big data, characteristics of big data, applications of big data, and at the end, we'll summarize what you have studied and we'll be taking a quick quiz for the same. So, friends, let's start. So let's know what is a data. In short, we all know that data is nothing but the information. So the information can be the quantity, the characters, or the symbols on which the operations are performed by the computer, which may be stored and transmitted in the form of electrical signals and recorded on the magnetical, optical, or mechanical recording media. So data, we know that it can be stored in a hard disk or it can be stored in a pen drive or a portable hard disk or on an optical device or some in CDs and everything. So data in short is nothing but the information. Now, we all know data is the information which can be stored onto a computer. So now the question comes when we are using an internet, when we are fetching the data from the outside, from other websites and all. So what is that data called as? So that data is nothing but a big data. So big data is also a data, but it is with a huge size. There is a huge amount of data which is floating around. So big data is a term which can be used to describe a collection of data that is huge in volume and yet growing exponential with time. I repeat, big data is nothing but the collection of data which is huge in volume, which is very much like which is in a large volume and which is keeping on growing with the time. So in short, such data is so large and complex that none of the traditional data management tools are able to store it or process it efficiently. So the various examples, if I want to talk about big data, is like, for example, the New York Stock Exchange generates about 1 terabytes of new trade data per day. The social media, for example, the Facebook generates 500 plus terabytes of data every day. So where is data is going to get stored? How is data is going to get how this data will be used for making the decisions? So that is a main question. So the on for example on Facebook, so generally the big data where the data which has been generated is nothing but the photos, the videos, the video uploads, the message exchange, the putting the comments, what we keep on putting the comments and all. So all that has to be stored because suppose if you want to access 1 week what I have accessed the data, what I have used, what I have commented 1 week ago on the Facebook, I'm able to see it, right? So that is nothing but my data is getting stored somewhere, right? My data is getting stored somewhere. So that is nothing but my big data. That is nothing but my big data which is getting stored. So we need to learn about how this data has been analyzed and how it has been used for decision making. The next example, if I have to give, is like a single jet engine can generate 10 plus terabytes of data in 30 minutes of flight time. With many thousand flights per day, generation of data reaches up to many petabytes. So this can be the best example of big data. Now, moving ahead, we come to what are the types of big data. So, big data is of three forms. Number one, structured. Number two, unstructured. Number three, semi structured. So, these are the three types of big data. So, let's see one by one. So, as a symbol says, when I say over here, unstructured, the symbol, structured, the symbol is over here. When I say it is unstructured, the symbol is in the form of files. When I say semi-structured, the symbol is in this form. So let's see one by one. So when we talk about the structured data is nothing but the data which has been organized, right? Which we already define the tables, we define the entities. For example, an employee table. I'm defining an employee table. I know what I need the data to be stored into my database. Right. For example, for employee database, I may take a for employee table, I may take an employee ID, I may take an employee name, the gender, the department to which the employee belongs. So this is nothing but my structured way of storing data. So this is an example of your structured data. Next, moving ahead, we come to about like what is unstructured data. So any data which is unknown or the structure is classified as unstructured data. Right? We don't know. It is not having a structure. From everywhere the data is getting floated. It is not organized. The tables are not been made. The data is not stored. In addition to the size as being huge, unstructured data poses multiple challenges in terms of its processing for deriving value out of it. So, like the best example of unstructured data is a typical example of unstructured data is a heterogeneous data source containing a combination of simple text files, images, videos. Nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive the value of it. Since this data is a raw from an a raw in the raw form or it is in an unstructured form. So we get a number of text files, images, videos, and all, but that data is not organized. Which text to use where, which image to use where, which video can be used for what purpose. So we don't know. All the data is in the raw form. So that is the data which is in the raw form or an unstructured format is known as unstructured data. Next, the best example of unstructured data is the output written by the Google search. For example, if I'm searching, like, give me the most, give me what is the formula for a, what is the formula for calculating the, for example, the percentage. So it might give me a number of websites, right? But it is not structured, right? It will give me n number of, it will, what it will search. I'm typing in my Google search as what is the formula for percentage. So in its search engine, wherever the word what appears, wherever the word percentage appears, formula appears, it will search from its database, and wherever these keywords are matching, it is going to give me the huge amount of links, right? So that is nothing but the output. I'm not getting, I may get the proper answer, and if I go on moving to the another pages, so there the words, the pattern gets matched, right? So I mean to say, what we want to say, that data is an unstructured data, right? The output written by the Google search is nothing but my unstructured data. For this is the image which we have put. Next is the next category is what do you mean by semi-structured data? The third category is a semi-structured data. So the semi-structured data can contain both the forms of data, that is structured as well as unstructured. Semi-structured is nothing but the combination of structured data as well as an unstructured data. So we can see the semi-structured data as a structured in the form, but it is actually not defined. So with example, for example, a table definition relational DBMS. So sometimes I'm defining a table and I'm trying to combine my video files. I'm defining an employee table, but with the employee, I'm trying to attach the employee videos and the what we say, the images and the text and all. But which image will belong to which employee, which video is belonging to which employee, I don't know. So it is a combination of my structure. Employee table will give me structure, but what videos, what text files, what comments are given by which employee, it will not get matched. So this is nothing but my semi-structured data, which is a combination of a structured as well as an unstructured data. So this is an example of semi-structured data. Now moving ahead, the next topic is characteristics of big data. So it is very important to know there are 5 V's, but we say it as the 4 V's. Nowadays we call it as the 4 V's of big data. Number one is volume, number two is variety, number third is velocity, and the fourth one is variability. So these are the 4 V's of big data: volume, variety, velocity, and variability. So let's see one by one. Volume, the name big data itself is related to the size, which is enormous and which is huge in size. The size of the data plays a very crucial role in determining the value out of the data. So volume is nothing but the huge in size, the data which is floating around, which is huge in size. So that defines my value, volume. Next is a variety. we have a variety of data which is floating around. There's a heterogeneous collection of data, the source of data from where it is getting flowed. I may have some PDFs, some monitor, some devices which have been getting like IoT based devices, which are giving me which are generating the data in petabytes every second. The photos, the videos, the audios. For example, the Spotify. Spotify is giving me every moment I get a playlist. So that is nothing but the variety of data I'm getting, right? So this is nothing but my variety. Next is the velocity. Velocity refers to speed of generation of the data. How fast the data is generated and processed to meet the demands determines the real potential in the data. So big data velocity deals with the speed at which the data flows in the form in from sources like business processes, applications, logs, networks, and the social media sites. The sensors which are used in like in the Mercedes car or the driverless cars, they are sensing the things and they're sending the data. They're floating the data. I can even if I'm using a driverless car, I can even get the details of 1 month back where my driver did an accident, at what speed the car was getting drive, right? How many were the holes were, how many were the speed breakers. So even I can the sensor will detect and it will give me the entire analytics for the same. So that is nothing but the velocity, the speed of generation of the data, the speed at which the data is getting generated. Now the next is nothing but the variability. So this refers to the inconsistency which can be shown by the data at the times, thus hampering the process of being able to handle and manage the data effectively. I am having an variable types of data. I'm having a variety of data. So there is an inconsistency. I cannot do the integrity constraints to my data. So sometimes it becomes difficult to handle data and take the business decisions. As we said, basically the big data is used basically, and the main importance of big data is nothing but to use the data, big data, for taking the business decisions. So variability is one of the constraints where we find the data, we find difficulty in segregating the data. So this was about the characteristics of data. So let's see the benefits of the big data, or we can say the applications of the big data. First, we'll move on to the applications of the big data. So your big data can be used in the media and entertainment industry. Big data can be used in government sectors. Big data can be used in healthcare industry. Big data can be used in education industry. Big data can be used in weather for detecting the weather patterns, the forecasting which we do or with the weather department does. Big data can be used in the transportation industry. Big data can be used in banking sector. So if you see the big data applications, we have the various industries. For example, the retail and the consumer, finances and the fraud services, web and the digital media, health and the life sciences, telecommunications, e-commerce and customer service. So here, these are the few examples of big data. Now, if you see this chart, big data is used in building and constructions. Big data is used in, let me take my pointer. Yeah. Big data is used in building and constructions. Big data is used to detect how many is the unemployment, how much is the unemployment in the country, how much electricity is generated. We can track in a month, suppose for a particular area or particular state, how many electricity has been used. That also we can do the calculation, that also the records can be maintained and the decisions can be taken. Even your big data is used in agriculture industry. Your big data is used in an education, in an insurance sector. Big data is used in your natural disasters. Big data is used for the tax for your tax calculations. Big data is mostly and highly used in the health and the welfare. Big data can be used in the political for taking the political decisions. So these are the few examples where applications where your big data can be used. Moving ahead, when we talk about the government sectors, there are various welfare schemes and all. So who has opted for which welfare schemes or what the government is doing? Again, that can be maintained in your big data database. Now, big data can be used. The cyber security, and big data is usually used for detecting the recognition. It is also used for the catching the tax invaders. So mostly the big data is like it can be used by the cybercrime and the cyber security department. So even it can be used by the Food and the Drug Administration. So big data, so when we talk about big data is used in education. So in education, for what purpose it will be used? Like for the data privacy and the security, for digital records of the students, for maintaining the attendance, for uploading the assignments, by correcting the assignments and all, for the quality of the digital content and resources, for internet access provided at home, like who is using whose Wi-Fi. The students keep on telling, I don't have a network. Even we can see whose network is working or whose network is not working. So that also can be, that also record data can be recorded in the education sector. Next is nothing but big data contribution to the healthcare. So into the healthcare also we can use the big data. Suppose there is centralized big data database. So we can see that suppose 10 hospitals are being connected to one entire, like there is a big hospital, for example AIMS hospital. So AIMS hospital is having a branches across India. So all that data has to be centralized, maintained. So what is the purchase data? What is the CRM data? What is the transaction data? What is geographical data? Health tracker, historic patient data, research data, EHR data. All this can be maintained in a centralized server or on the cloud. So that is nothing but the big data. Or even so, for example, the best example of healthcare is COVID. So Arogya Setu app. So it is connecting the entire India. It has connected the entire India, who has been affected, who is not affected. So that is nothing but my big data which is getting floated. So this is nothing. Then the next example of the next example of big data is nothing but for it is used for detecting the weather patterns. So whenever, like suppose we say that tomorrow there is going to be rainfall, tomorrow there's a cloudy, tomorrow there is a sunshine. So all like after 1 week, afterwards also data we can do it, we can detect it. So that is nothing but the weather forecasting department works. So for the natural disasters, earthquake is going to come or not, which where is the, like what is the water level of the seas and all, even that can be detected and the precautions can be taken at the earlier, right? So this is again the example, it is again the best example of weather forecast. For it is a big data, the big data can be used for your detecting your weather patterns. So next, the best example is big data is used in the transportation industry. So the GPS, where is the traffic? We use the GPS usually. So to track, we open the map, Google Map, and we try to track where is the traffic, and we the Google itself reroutes yourself. Suppose if there is a traffic on the way, so we can even like big data nowadays is used in the transportation industry. So next, the best example is big data is used in the banking sector. Now you say it is a core banking. Wherever you go, in whichever ATM machine you go, you can withdraw the money. So how is it possible? All banks are being centralized, connected. You go, you have an ICICI bank card, and you go into SBI machine, ATM machine, you can withdraw the amount. So how SBI machine is detecting your ICICI card, your account, and you are able to withdraw the amount. So that is nothing but the core banking. Core banking means what? All the banks have been brought into the cloud, right? The big data is getting floated. So big data is mostly and widely used in your banking sector. You go to any shopping center, any mall, and you're able to scratch your card and you're able to pay it. So how it is used? The when the big, suppose for example big bazaar is using an SDFC machine, ATM, this thing, card swapping machine, but you have an ICICI card, you're able to swipe it and you're able to withdraw them, you're able to pay your bills. So that is again a big data, where big data is floating and your data has been stored onto the over the internet, right? So all the credit cards, the internet banking, the debit cards, the Google Pay and all, that is nothing but the big data plays an important role for doing the banking transactions. So another examples are auto driving car, as I mentioned, secure air traffic system, air traffic, the way the planes and all they do. So it is a secure air traffic system. Where is the traffic? How many planes? Suppose it's across the big data, the servers are connecting. When we talk about secure air traffic system, now if you could see, there is no single error into the air traffic. So air traffic means not on the roads; it is on the clouds or the planes which are moving. So across the world, the planes come, they land up, they do all the things. So what is this data? This data is stored on the cloud, right? Which suppose which plane is going to land up in Mumbai. Suppose the British Airways is coming from Dubai, the planes are coming from Singapore, the planes are coming, and there are some planes are going from India. So how they do all these things? This is nothing but the secure air traffic system. So that is nothing but the big data which is generated, which is getting managed. So this is the best example of big data. Then you have a virtual personal assistant, for example, Alexa. The best example is Alexa. So Alexa, what Alexa does, Alexa is able to place your order. Alexa is able to give you anything, whatever you want. If you ask Alexa, Alexa, what last week, how many times have on Thursday, like did I on my TV? So even it will give you that. The Alexa will respond to that things. If you want Alexa to place an order for something, if she will say, if you want Alexa to give you the news for the India, if you want to give if you ask her to give the news for foreign countries, or what was a scenario 1 week before in US news, even that will give. So all this data has been stored in a database, and the virtual personal assistant is able to answer you. The Alexa is able to answer you. So that is nothing but the big data, right? So the nowadays the big data is widely used in IoT. Every machines are coming. IoT means that is nothing but the Internet of Things. So everything is on now. Everything is on internet. So the best example of IoT you can say is the driverless car. The sensors have been made. The sensors have been put the agriculture. Suppose you have an agriculture, have your farm, you have your agriculture land there, the farm in your some village, and you're sitting in a suppose you're sitting in US. You want to give the water, you want to water to your farm. So it is easily, you can just click it, and the sensors are based into your agricultural farm. You can just click from US or one button in your mobile, and the sensor will start, and automatically your entire farm will get watered. So that is nothing but the IoT sensors. Now, Mercedes Benz and all, they're able to, they have an IoT sensors, automatic cars. That is nothing but the IoT sensors, right? So in healthcare also, the IoTs are used. For instance, the fidget band which you're using. So that is nothing, again, nothing but your IoT device. And again, that data is getting flowed. The data is getting stored on the cloud. Suppose you want to see how many kilometers I walked last month. Calculate and give it to me. Even you're able to see that figure, and this month how many weight loss I did. So even through the IoT fidgets and all IoT devices, you are able to do it. But where this data is getting stored, this data is getting stored on the cloud. That is nothing but a huge amount of data. That is again a big data. So as I said, the big data is used in education sector, in the energy sector, in the media and the entertainment sector, etc. So here we come to an end of our session. So just to summarize, what we have studied is, we studied about the big data. It is nothing but the data is huge in size, and we studied the examples of big data for stock exchange, social media, and jet engines, etc. Then again, we studied the various types of big data, which is structured, unstructured, and semi-structured. And at last, we studied the various characteristics of big data. That is nothing but the four V's of big data: volume, variety, velocity, and variability. And at the last, we studied the various applications of big data. And big data is not that is the advantage of big data. The advantage of big data is nothing but big data is used for basically, and mainly the big data is used for making the decisions. It is used for taking the business decisions. So that's all for this session. Thank you. For any queries, you can contact me the on my email ID, on my number which has been provided. Thank you.